hands together for Matan.
Hello, I'm Matan, and I want to tell you about the Futamura projections, which are an idea Dr. Futamura had about compilers in the late 70s. And I'm going to start with theory, we're going to start with a thought experiment, and at the end, I'm going to bring it back to the real world and tell you what's been done since the 70s. So we're talking about compilers, and we have a thought experiment. So in our thought experiment, what is a program? A program is a function that takes input and produces output. That's it. One input, one output. Thought experiment, bear with me. And even in our thought experiment, programs do not come fully formed, sprung out of the forehead of Zeus. They start out as source code, and that's why we need to have compilers. So what is a compiler? A compiler is a function that takes in source code and puts out a function that takes input and produces output, which is a program. Great. In addition to compilers, we also have interpreters. Interpreters take two parameters. They take source code, they take user input, and they produce user output. They produce output. So far, so good. And one of the facts of life is that interpreters are much easier to write than compilers. It's just the way it is. So we know how to write interpreters. We know how to write compilers. Everything's good so far. So now we introduce the idea of partial evaluation. What is partial evaluation? Again, it's a function that takes two parameters. The first parameter is a function that takes two parameters and produces an output. The second parameter is some sort of value. And it produces a function that takes one input and produces one output. And what does it do? It partially evaluates the function. It basically takes the second parameter you give it and makes it so that you can stuff this parameter in the first parameter you give it, so you get a function that does whatever calling those two functions with the two parameters would give you. And you can do it naively by, say, just keeping the value from before for later, and then when you get the second value, you call the function with the two values. Or you can do it in a smart way in which you can replace all the occurrences of the parameter with the value you got, so you have like an optimized program. And then you can do all the optimization tricks, escape analysis, inlining, whatever, and get an optimized function that does one thing. Can you see where I'm going with this? Interpreters, as we said, are a function that takes two parameters. We can put that into the partial evaluator. For the second parameter, we'll put in, say, some source code. And what did we get? We get a function that takes a value, produces an output. The value it takes would be input. The output would be the output of the program. So what we just did is compiled. We just did compilation. But we didn't write a compiler at any point. We had an interpreter, but now we compiled something. So yeah, that's pretty amazing, in my opinion. And that's called the first Futamura projection. And what that basically means is that we don't have to write compilers if we have a good partial evaluator. We can just write interpreters, which, as I said, is much easier. But we didn't actually get a compiler. We just did compilation. So what if I want to make a compiler? If a compiler is, like we said, a function that receives a source code and produces a program. Well, the partial evaluator is a function that takes two parameters. And we can stuff that in as the first parameter of the partial evaluator. And as the input, we can put in, say, our interpreter. And then we get a function that takes an input, which is source code, and produces output, which is a program. And that's a compiler. So we just made a compiler. And then we can do that same thing a third time. And what we get is we don't even have to do all this mess just to get a compiler. We can just put in an interpreter and get out a compiler. And at basically no cost. And if our partial evaluator is any good, if it does all the optimization that it can do, then the compiler that we get as a result would be actually pretty good. Anyway, that's the theory. That's the first, second, and third Futamura projections. And back to the real world, all this talk about function, we actually have this today. It's called GraalVM. It's made by Oracle. It's basically a Java virtual machine. And there exists a framework for it, which is part of it. It's called Truffle. And what it does, it basically allows you to implement an interpreter. And it does this partial evaluation business and gives you a compiler, which can be either a head-of-time compiler or a just-in-time compiler working on a Java VM for the language. And they implemented a JavaScript in it and got performance results that are, they say, competitive with V8, which is impressive because V8 is like a real thing which people hand tune, and this is basically magic. And they also implemented it for Ruby, which is used in production. And would it work for Go? Well, they also implemented LLVM bitcode. They called it Sulong, which means Velociraptor in Chinese, which I think is cool. And theoretically, LLVM Go is a thing, and LLVM Go produces LLVM bitcode, which Graal can write, but that doesn't work at the moment because reasons, because LLVM Go is too complicated for what Graal can do right now. But maybe if you would like it to work, then you can work on that. And that's my talk. Thank you very much.